Let's look at this problem. We need to determine the support reactions for this structure, this rigid body. We have different types of supports. We have a ball and socket joint at point A right here. And we have a smooth journal bearing at B. And we have a roller support at C. And we are given the load, two forces given as Cartesian vectors, F1 and F2. So this is a rigid body 3D problem. So right away, you need to know that for one free body diagram for a rigid body 3D problem, we're going to have um, overall 6 scalar equations, and we can solve for 6 unknowns. Okay, so let's draw our free body diagram. So we're going to draw the free body diagram. So this is our x direction, y direction, and z direction. We have the applied force. F2 is only along the negative x direction, so that's 16 kilonewton in this direction. F1, it has 3 kilonewton in the x direction, -2, so that's 2 in this direction, and then -9 along the z direction, so vertical down like this, 9. So those are the applied forces, but what about the support reactions? So at point C, we have a roller support, so only one support reactions vertical up. I'm going to call it CZ because it's along the z direction. Point A, because we have a ball and socket joint, ball and socket joint allows rotation, therefore it does not exert any moments, but it does not allow translation in any direction, therefore overall 3 force reaction, AX, AY, and lastly AZ. What about the smooth journal bearing at point B? If you remember, it does not allow force in the x and z direction, so we will have bx and bz. If the journal bearing is used by itself, it also does not allow rotation, therefore it will also provide moment support. However, because this journal bearing is used together with other supports, in this case, you do not need to rely on the journal bearing to provide the moment support. Therefore, it does not have moment support in this case. Okay, so as you can see from this free body diagram, we have overall 6 scalar unknowns, AX, AY, AZ, BX, BZ, CZ, and again, one rigid body 3D equilibrium problem. From this free body diagram, we can write overall 6 scalar equations and 6 equations, 6 unknowns. We can solve for all of them. First equation, resultant force along the x direction. We will have our AX positive plus BX positive plus the 3, which is also positive here, and then minus the 16, that equals to 0. First equation, resultant force along the y direction. We will have AY, and then minus the 2 right here equals to 0. Resultant force along the z direction, we have AZ plus BZ plus CZ, and then we have the -9, so -9 equals to 0. And then the resultant moment about the x-axis, AX, AY, AZ, all 3 forces pass through point A, pass through the x-axis, the y-axis, and z-axis. Therefore, the AX, AY, and AZ forces do not have moments about any of the x or y or z axes. Okay, all right. Bx is parallel with the x-axis, does not create moment about x-axis. Bz, however, does create moment about x-axis. It's counterclockwise with a moment arm of 0.4 plus 0.4, so 0.8 meter. So we will have our Bz times 0.8. And then don't forget our CZ here in the same direction as BZ, but the moment arm is 0.4 plus 0.4 plus another 0.4. Therefore, it's a CZ times 1.2. And then this 9 kilonewton force creates clockwise rotation about the x-axis with a moment arm of 0.4 meter. So 9 times 0.4 equals to 0. So that's everything. The 2 kilonewton force passes through the x-axis, no moment. This one right here, the 3 kilonewton force parallel to x-axis, no moment. 16 kilonewton force parallel to the x-axis, no moment. So that's everything about x-axis. Moving on to the moment about the y-axis. So we will have, again, AX, AY, AZ, and BX and BZ, all these forces pass through y-axis. So they do not have moments about y-axis. Okay, this 16 kilonewton force also passed through y-axis, no moment. Okay, the 3 kilonewton force passed through y-axis as well, no moment. The 2 kilonewton force parallel to the y-axis, no moment. All right, so only this 9 kilonewton force and CZ. So the 9 kilonewton force has a moment arm of this 0.4 meter right here, and it's clockwise, so negative 9 times 0.4. Okay, this 0.4 meter and this 0.4 meter are not the same thing, by the way. And then CZ is creating counterclockwise moments about y-axis, so positive moment arm of 0.6 meter. Okay, and lastly about the z-axis. All right, once again, AX, AY, AZ passing through z-axis, no moment. Okay, CZ is parallel to that, no moment. BZ parallel to that, no moment. All right, so BX does have moment about the z-axis. Okay, it is clockwise with a moment arm of 0.4 plus 0.4, 0.8 meter. What about the other forces? The 16 kilonewton force counterclockwise about the z-axis with a moment arm of 1.2 meter. Okay, the 9 kilonewton force parallel to z-axis, no moment. The 2 kilonewton force creates counterclockwise moment about the z-axis with a moment arm of this 0.4 meter plus 2 times 0.4. And then the 3 kilonewton force creating clockwise rotation about z-axis, so negative moment with a moment arm of this 0.4 meter equals to 0. All right, that is your 6 equations with the 6 unknowns, AX, AY, AZ, BX, BZ, and CZ. You can solve for all of them. As a result, AX equals to negative 10.5 kilonewton, AY equals to 2 kilonewton, AZ equals to 7.5 kilonewton, BX 23.5 kilonewton, BZ negative 4.5 kilonewton. Negative sign indicates that the direction is opposite to what we previously assumed, and CZ is 6 kilonewton. And that's the final answer to this problem.